It may sound too fanciful to believe. It's a plan to harvest solar energy from space and send it back to Earth using extremely precise electromagnetic waves. Although one may doubt whether such a plan can be realized, Martin Soltau, co-chair of the Space Energy Initiative, SEI, a collaboration between academics and industry practitioners, says it could be implemented by 2035. The Space Energy Initiative is working on a project called Cassiopeia, which is based on a plan to put a constellation of very large satellites into high Earth orbit. Once deployed, the satellites will harvest and collect solar energy and then send it back to Earth. The possibilities are virtually unlimited, Soltau says. In theory, these satellites could provide the entire world with all the power it needs in 2050. He goes on to say, there is enough space in Earth's orbit for solar-powered satellites, and of course the supply of solar energy is enormous, as a small portion of the area around the geostationary orbit receives more than 100 times annually the amount of energy it is expected to use. All of humanity in the year 2050. Earlier this year, the UK government announced £3 million of funding for space solar projects, SBSP, after an engineering study by consultancy Fraser Nash concluded the technology was viable. SEI hopes to get a large portion of that money. Its satellites are made of hundreds of thousands of identical small units that are produced in factories on Earth, then assembled in space by autonomous robots, which will also be responsible for the servicing and maintenance work of those satellites. The solar energy collected by the satellites is then converted into high-frequency radio waves, which are transmitted to a processed antenna on the ground, which in turn converts those radio waves into electricity. Each satellite can provide about 2 gigawatts of power in the grid, making each satellite comparable to a nuclear power plant in terms of energy production. Here on Earth, sunlight spreads through the atmosphere, but in space it comes directly from the sun without any interference. So a space solar panel can collect more energy than a similar-sized solar panel on Earth. Similar projects are under development elsewhere in the world. In the United States, for example, the Air Force Research Laboratory, AFRL, is working on some critical technologies needed for such a system, in a project known as Solar Space Progressive Research and Demonstrations, SSPIDR. Technologies the project is working on include improving the efficiencies of solar cells, beam shaping and frequency conversion from solar energy to radio waves, as well as reducing large temperature fluctuations on spacecraft components, and creating designs for deployable structures in space. Late last year, the team successfully demonstrated new components for so-called sandwich tiles, 3-layer panels used to convert solar energy into radio waves. Ultra-precise electromagnetic waves, or microwaves, may seem alarming, but their use on Earth has proven to be effective and safe for both humans and wildlife. The beam is a very short wave, so it's like the Wi-Fi we use all the time, and it's low in intensity, about a quarter of the intensity of the midday sun, Soltau says. If you are on the equator in the desert, the amount of power that can be obtained is about 1,000 watts per square meter, and for these panels the power is about a quarter, about 240 watts per square meter. So they are safe in nature, Soltau explains.